Hey everybody, we're going to go ahead and get started with Chapter 9. This is the same as the lesson that I would do in class. The examples we're going to follow through on the note sheet, we're going to be talking in this chapter about exponents and how we can use exponents and actually how those exponents relate to radicals, that is like square roots and such. So we're going to be making those connections, but we're going to be starting with a little bit of review of Algebra 1. So this should look familiar to you. Video 911, that is the first video of the first standard from Unit 9, and we are talking about the properties of integer exponents. Now our standard is to simplify expressions with rational exponents. Just a reminder, rational numbers are numbers that can be written as a fraction or as a decimal that they repeat or terminate. Those are rational numbers, but we're going to be using them in the form of fractions as exponents. Okay, so just a review of the exponent properties. Our zero exponent property says that any base to the power of 0 will equal 1. That is, any number as long as the base to the power of 0 will equal 1. If this negative was on the outside, for example like this would be -1 because the negative is not included. But this is our zero exponent property. The multiplication property says that if you have a base a with an exponent of m and another base a with an exponent of n, that you would add those exponents together. Okay, so for example, if I have x to the fourth power times x to the second power, I get x to the sixth power. If I apply that with numbers as a base, like 3 to the fourth power times 3 to the second power, I do not get 9 to the sixth, I get 3 to the sixth. So this is really important to keep in mind. Our power product, the power property is power to a power. That is that if I have a base raised to a power and then I raise that to a higher power or another power, does not matter, that this will equal a to the m times n. Okay, let's try that. If I have x to the fourth and I go ahead and square it, I get x to the eighth. The same applies if I use a number base, like 3 to the fourth to the second is 3 to the eighth. A negative exponent property. The negative exponent property says that if I have any exponent to any base to a negative power, I'm going to use 1, that this equals 1 over a to the first power. So a to the negative second is 1 over a squared. Okay, this is actually it's written as a reciprocal. It's like an inverse. So it starts, it looks like it's written as an integer perhaps, and then it turns into a fraction, but this can be done the other way. If I have 1 over a to the negative third power, just using a different number here, this actually is a cubed, so it moves itself from the fraction to the whole number again, for example. All right, my division property, if I have a base m, or a to the m over a to the n, I get a to the m minus n. Please keep in mind whenever I'm using these properties, the multiplication or the division property, my bases have to be the same. That is that I cannot have something, for example, like 2 to the 10th power over 3 to the 5th power and do anything with that. I have to have the same base. So 2 to the 10th over 2 to the 5th, this will be 2 to the 5th because I'm going to subtract 10 minus 5. All right, so now we're going to put these to use, and we've got 7 practice problems we're going to try. Okay, if you feel confident in these, please go ahead and pause and then just try them on your own and then come back. If you want to work through them with me, I'm going to talk through each one of them, but that could save you a little bit of time if you just want to attempt them and see how they turn out. So go ahead and pause now if your goal is to just try them and then come back and check with me. So this is going to be 1 over 4 squared, but since I know what 4 squared is, I'm going to leave my answer as 1 over 16. The next one is I'm going to use this cube. I'm going to use two properties here. First of all, I'm going to have power to a power. And the second property I'm going to use is the negative exponent property. So I'm going to do it in that order actually. It could be done in either order, but this is the order I'm choosing. So I will have x to the negative third, and then I will have y to the negative sixth. And then I'm going to write that as they both move to the denominator. Okay. The next one, the only thing that has the negative exponent is the x. So the only thing that I'm going to have to move or change here is that I'm moving those to the denominator. So the 5y, since they do not have negative exponents, will remain, and the x to the fourth will move. Once a base that has the negative exponent is relocated, it becomes a positive exponent. That's important too. Number 4, because these negative are in the denominator, I can handle this two-way. I can say, well, this has to move to the numerator, which becomes a to the fifth times a to the eighth, which then becomes a to the 13th. And then I could handle this a different way. I could have been like, well, I should use the division rule, and that's subtraction. So a to the fifth minus the negative 8, which still becomes a to the 13th. So there's two ways of looking at it, and you get the same result. The next one, the 10 over 25 part is like reducing a fraction, just a regular fraction, 10 over 20 or 25 over 10. There's no subtraction involved. It's a plain old fraction, 25 over 10. So I'm going to handle that part first, and that is going to be 5 over 2. Then I'm going to continue and handle the r's. If I did 7 minus 9, I would get a result of negative 2. So that would be r to the negative second. And then if I handle the z's, I would have 5 minus an exponent of 1, so that would be 4, so z to the fourth power. But I'm not allowed to leave, or I'm not going to be asked to leave the negative exponents in the numerator. So I'm going to rewrite this, leaving the 5 in the numerator, leaving the z to the fourth in the numerator, the 2 stays in the denominator, and the r squared goes to the bottom. So this would be the final result for number 5. All right, two more. These are just going to have a couple more different combinations of the properties. Properties are still there. We're just going to mix them up and kind of put them together differently. So this one, I'm going to start handling this part first by making sure that I use power to the power. So that would be 4 to the negative second and x to the negative 10th. And since this is all multiplication, I don't really need the parentheses once I've taken care of the exponent. So I have 3 and then x to the negative second. Next thing I can do is I can relocate anything with a negative exponent. So I have 3 that does not have a negative exponent over x squared, and I'm going to make that 16 and x to the 10th, and then I'm going to add my x to the 10th and x squared exponents together to give me 3/16, and then in the denominator x to the 12th. So this would be better pronounced as 3 over 16x to the 12th. And our last example, I'm going to handle all of the powers on the outside first. That's my first step, and then I will deal with moving things where they need to go. So this is 3 to the negative first and x to the negative second. Because it's all multiplication, I'm going to have 3 to the negative second, x to the negative 10th, and in the denominator, 3 to the negative second and x to the negative fourth. So it seems as though everything from the numerator is moving to the denominator and everything from the denominator is going to the numerator. And you may be able to handle this in a variety of different in a different order, or if you can combine steps, you're okay doing that. But I'm going to take it step by step so everybody can see. That's going to be 3 to the negative, or 3 to the, let me erase that. I don't even want it on there. There we go. 3 squared is up on the top and x to the fourth is up on the top. And then my 3 and x squared and 3 squared and x to the 10th. Then I'm going to start combining things in the denominator. So I have 3 squared x to the fourth over, and I'm going to have 3 cubed and an x to the 12th. And now I'm going to use the division or the subtraction with my exponents, leaving me only a 3 in the denominator because it's 3 to the first power if I take a look at these two. And then these two are going to leave me x to the negative 8th, which means it's in the denominator. So what goes in my numerator? A 1. And that is my final answer for this one. All right, you guys, really good job. We're going to get to some practice on that now.